A very warm welcome, everyone. As we continue today's conversations, we now turn our attention to a critical pillar of India's battery ambitions, manufacturing. Building a globally competitive battery ecosystem will require much more than demand alone. It will depend on strengthening domestic manufacturing capabilities across materials, cells, components, equipment, talent, and supply chain. This next discussion, Building the Battery Manufacturing Backbone for India's Energy Transition, will explore what it takes to build the manufacturing backbone needed to support India's clean energy transition and long-term industrial competitiveness. To moderate this session, please join me in welcoming Ms. Swasti Raizada, Senior Policy Advisor with the Energy Program at the International Institute for Sustainable Development, IISD. Ms. Raizada's work focuses on energy policy, regulatory governance, project finance, and sustainable energy transitions. Prior to IISD, she worked with Deloitte Consulting on electricity reforms, net zero initiatives, energy access, and utility sector transformation.
Joining her on the stage are our distinguished panelists. Dr. Kuldeep Rana is currently serving as Scientist Director at MNRE Government of India, where he is overseeing energy storage, circular economy, and policy-related initiatives since 2023. We also welcome Mr. Vikramaditya Gaurineni, Executive Director, Amara Raja Energy and Mobility. Mr. Vikramaditya is leading the establishment of one of India's largest advanced chemistry cell and battery pack manufacturing facility. Please welcome Mr. Ankur Khaitan, Managing Director and CEO, TACC Limited. With more than 17 years of experience in energy and advanced materials, Mr. Ankur is leading efforts to commercialize India's graphite anode and graphene technologies, advancing domestic capabilities in critical battery minerals.
Next, please welcome Mr. Kirti Verma, co-founder and chief operating officer at Altman. Mr. Kirti is an accomplished entrepreneur and operations leader who leads Altman's strategy and operations across lithium supply chains and battery materials, helping build resilient domestic supply chains for India's battery ecosystem. We also welcome Dr. Yogesh Kumar Sharma, professor at IIT Roorkee and co-founder and head of research at Indie Energy. Dr. Sharma has over 16 years of experience developing advanced energy storage technologies, including lithium-ion batteries, sodium-ion batteries, and solid-state batteries. And finally, we welcome Dr. Akansha Tyagi, Senior Program Lead at CEEW, an experimental chemist by training. Dr. Akansha co-leads CEEW's Technology Futures work on clean energy manufacturing, supply chains, and circular economy. Her work focuses on supporting a responsible and inclusive energy transition in India. Please join me in welcoming our moderator and panelists. Over to you, Swasti.
Thank you, and I think the post-lunch session is always hard, and I have a really full panel. So firstly, I think I want to really thank my panelists for being here. I think the morning session was just so reinvigorating. I'm hoping that with this panel discussion, we can revive that and not really let it dip. So it just makes my task difficult. But I do think that this is one of the most important dialogues of today, because this is where it actually gets into deeper conversations about where the challenges are and where the opportunities are. I want to build on some of the morning conversations. I think Mr. Rahul had mentioned, we should probably not be just thinking about leapfrogging anymore, but pole vaulting. I think that was a really good anchoring of everything we want to discuss in this panel, which is around next generation chemistries, what are the challenges when we think about anode, cathode manufacturing in India, talking about more deeper issues. Because India has seen significant investments across the battery value chain, and we're just getting started in the country today. There's almost 60 gigawatt hour of announced capacity, which is under development. And we've also seen several schemes being announced by the Government of India. Also at the subnational level, we are seeing a lot of momentum by state governments. We're seeing industrial policies at the state government really talking about battery manufacturing as a thrust sector, as a sunrise sector. So there's a lot of opportunity that is sitting at the subnational level as well. At ISD, we've been doing a lot of work at looking at state industrial policies and how that's really supporting the battery manufacturing ecosystem when it comes to several components, equipment that is needed for then the manufacturing push. And that's what we are here to talk about today. So the real question is no longer whether India will manufacture batteries, I think. I think everyone in this room is probably aware of this today. And the question that we really want to ask in this panel instead is, what kind of battery manufacturing ecosystem will India build? And can it compete globally? What will it take for us to build a globally competitive ecosystem? So with that, let me start with the first very simple question for all the panelists, and we can go in any order of maybe in the direction that we are sitting in. So if you can all each give me a 90-second quick answer to, if you had to identify one constraint that would determine whether India becomes a globally competitive battery manufacturing hub by 2035. So this can be like a long-term visioning exercise that we do collectively. What would that one constraint be? And I want to talk about constraints because it can help us get into the details of some of the challenges further. So maybe starting with you, Mr. Khaitan.
Thank you, Swasti, and thank you for this wonderful start actually, because we have been hearing constraints from, I don't know, from 2019, from around COVID era, because every 3 year when we see a report from an analyst, the next 3 years look wonderful, and it is in fact a great pleasure today that while we sit, we are seeing on-ground action happening in India, both in terms of manufacturing of cells as well as components. When we talk about constraints, then before that, one thing which is very visible today is that India is showing as a very, very big global manufacturing hub, and this is not just in terms of rosy speeches, but if we really see that in some time back, a lot of investments from US, Europe, everything was flowing towards China. People wanted a local presence in China. Now people have started realizing that India is a very, very big alternative where it comes to speed of execution, the permissions, the availability of good manpower, right from the lowest level to the best of the best R&D people here. So if we talk about a simple constraint is that one side, a private investor, private companies, the big private companies, they have to come forward towards taking certain amount of risk. And at the other side, government has already started understanding, and the real hope, the real vision is that the government also supports the private companies in terms of the long-term growth. I'm not talking in terms of grants, I'm not talking in terms of upfront money, but in reality, supporting the people who are actually investing to becoming these ecosystem, because they will the standing would need for first 4 to 5 years of support from the government, and then the industry becomes self-sustaining. So this is the 90-second I could have said.
Thank you. We'll get into the details of, I think, what you alluded to. Go ahead, Akansha. Yeah.
Thank you. I think what we have been hearing since morning and also in many such similar platforms is that there is a lot of on-ground activity and actions happening. So the biggest constraint that I see in all of that action getting translated into something concrete and tangible is the qualification and the quality assurance part. I think when the challenge to basically manufacturing something at a startup level, at like a research level, to something that actually finds place in a commercial value chain or their supply chain, I think the quality assurance becomes a big bottleneck. And I think today, at the scale, all of the innovation and manufacturing that's happening, we need to have similar focus on bringing up a lot of testing and quality assurance infrastructure, so that there is the gestation period for these innovations to quickly commercialize can be reduced, and we can actually see more tangible things. So I can build on that later, but I think the constraint in my understanding is a good, robust infrastructure of multiple testing labs and the qualifications that we are running, and also even the SOPs that are followed within these testing infrastructure also becomes important. Yeah.
Interesting point, yeah. I think the lab to market cycle and the standardization that's needed around it, yes. I think from an Amar Raja perspective, it'll be good to know how you see the ecosystem and what are the constraints, that still reside in India, yeah.
Thanks, Asti. I think, first of all, if I look at where we are in the journey, I'm actually pretty content. I think just the other day, they talked about 10% of new car sales in India have crossed as we have become electric. So I think if we look at where we were 5 years back, that's definitely huge progress. And I think naturally, the next stage is more and more localization. Are we making more of the car in India today? And now, naturally, cell is where we need to kind of stabilize. And I'm also very happy to see that there's a lot of good efforts happening on the materials side, and many of my co-panelists are working on that front. But when I have to say where the constraint lies, it's the pressure is not equitable today. Today, OEMs have been able to reach a 10% penetration in India because there is a lot of protection that comes in terms of government. I think the automotive industry has been the king of manufacturing in India and has been a highly protected one at that. So when cell manufacturers are now in the process of investing billions of dollars, and I would say, the PLI, we can always argue whether it was good or bad or it was a misfire, but the fact is market conditions have driven, there's a 50 gigawatt hour outside of the PLI that's being added by several private players. But who's going to foot the bill for industrialization? If we're going to be 20%, 30% more expensive on day one, there's not an OE customer in India out of patriotic sentiment that's willing to pay that. So I think that's a question that has to be answered.
Very important point, I think. Yes, I think Dr. Rana, from your perspective, it'll be very interesting to know the things that are happening on the BESS side and how that speaks to then the manufacturing piece in terms of how do we support our battery manufacturers within the country to scale up.
Yeah. So I think that you have asked that constraint. So I would say that it's very difficult to say what is the single out the constraints. So it has been told that since 2019, but I would say that we are hearing the same problem or most of the same problem, not all, from since 2008 when we were working in the lab. And I think the Professor Yogis will agree with that. So the constraint is not single. So we have the constraint from the upstream to downstream, midstream. So mostly the problem comes in the component manufacturing and then cell manufacturing. In the cell manufacturing also, stabilizing a line, the gigafactory or the factory, that line is one of the main constraints. And for that, if you see some reports, there are published reports of the European market, so that we are facing similar problem what the Europe and the US is facing. That we have the R&D, of the lower to higher TRL, but the major bottleneck is from the academic pilot to make the commercial pilots. And then when the commercial pilots, we say that it will be almost being copied in the larger gigafactories. That is the major bottlenecks, what I feel. And adding in that, so definitely that supply chain is one bigger problem, but at least commercial manufacturing. And then the other problem is that even we have the TOT, the technology transfer with the Chinese company or any other companies, but still that they are stabilizing the line is a big problem because still we don't have the trained manpower. The technology transfer won't help in that manners. So because there are n number of steps in the gigafactory, so each steps we require the trained manpower who has the experience working on these gigafactories. So the major problem is the bottlenecks, we can say, is from the academic pilots to the commercial pilots. Thank you.
Important, I think, layer to deepen the innovation stack for India. Yeah. Please go ahead. Yes.
Thank you, Swasti. So I would think the larger constraint when you look at where India needs to be 10 years down the line comes from a lack of cross-industry collaboration. So when you look at the entire value chain, you have 4 distinctly different industries. You have the mining, you have the chemical processing, you have the battery manufacturing ecosystem, and then your automotive and the BESS. Everyone is coming in from their own perspective. Everyone is making their own investments, their own setups. But one thing that we've seen globally, a lot of the companies that have tried to set up this at large scale, without cross-boundary linkages, it's very difficult to scale. For example, if you look at the Chinese counterparts, they're well entrenched between all the sectors, either through direct investments or through collaboration or even through R&D partnerships as well, for developing the final product that is suitable for the end consumer from a ground level. So this evolution is something that is still lacking. I think over the course of the next 2-3 years, I think we'll see a lot of the material companies, cell companies and OEMs start linking up together. And once we link up together, the final product that we can develop together can have a shorter cycle life, 2 to 3 years. The execution risk becomes much lesser. The cost viability becomes much higher as well. So I think that would enable or unlock large-scale manufacturing in the country.
No, I think that's a very interesting point. We actually, in the work that we were doing on the research side, we also discovered how the clustering approach in China really makes a difference when it comes to costs and reduction of costs. And I think that's something that we need to work more in terms of, regional approaches, cluster-based approaches between the competitive federalism that is already going on between states on, attracting anchor investors. So yes, Mr. Yogesh, it'll be interesting to know your perspective on this, especially from the research side. Yes.
Thank you, Swasti. Actually, if I will summarize all what my fellow panelists said, there are 5M for any successful product. The first one is 5M means market, money, machines, manpower, and material. So 2 we have, market and money we have. Government is also giving huge, but rest 3 is difficult. Maybe I will give you better idea when we will come to the next detailed discussion. But the main constraint in machine, material, and manpower. Adequate manpower, what Kuldeep said, that every challenge, you put to gigafactory today, and you will get the 5 kg material, 5 ton material. Every time material will be different. And then your efficiency of your machines is again a challenge. You need to rely on imports. So there is a huge need to be done. And I hope ministries are taking care of that now. And I'm sure, we have to do something in the next 5 years down the line. Probably we will be having a better place. Thank you.
Yeah, thank you, Dr. Yogesh. I think that was a very important point on the equipment and machinery, and Government of India has been taking steps in the latest budgets. They've been reducing the custom duties to enable further, transfer to the extent that can happen. I'll build on that point because I think it'll be interesting, actually, Mr. Khaitan, to get your perspective on this. The entire discussion on battery manufacturing has, to a large extent in mainstream, has been limited to the gigawatt hour capacity addition that we've seen in the country. But eventually that success still depends on how much sourcing of the components can we do locally. So as somebody who's looking at anode manufacturing at such a deep level and also at a global level, at a global scale, can you tell us a little bit about the anode manufacturing journey of yours and the challenges, especially from the, if there are any in terms of, the machinery that we need for next-gen chemistries that you're thinking about from the, the vast R&D that you, sort of are supporting at TAC? Would be interesting to know your perspective on that.
Yep. Actually, this is very interesting because these are realizations all of us have in terms of machinery, in terms of equipment, in terms of manpower, in terms of knowledge. And while HEG has been into the graphite business for last 50 years, and it is the single location largest plant in the world, we built up from our own knowledge of carbon and graphite, and that's how the Advanced Carbons company came into picture. And the whole idea was to have, there was a big pivot because Bhilwara Group is into manufacturing and the DNA has been manufacturing. But in TAC, we very well understood that it has to be a complete pivot and the engine has to be the R&D. Now, R&D making an engine is a very difficult choice when you have a P&L, when you have a timeline, when you have a payback associated, when you have a focus on customer, everything. But at the same time, there was no choice. And this is where we progressed in a very interesting way, because we have our 1/3 of the team is towards R&D alone, right from material science to people and chemistry. And when we speak about the different projects of TRL level 4 to 7, 4 to 10, then we have almost 30% of the projects which are at a high TRL level. Now, this gives us encouragement because ultimately the demo plant is there to allow you to fail as many times as you want. And today, when my dear panelists, he just spoke about the collaboration between people. So again, when we speak with cell companies, when we speak with even the raw material suppliers, it's no more a commodity business. It is purely a growing together business. I cannot supply a material to a customer and he will not come back to me that your material is not performed and sorry, bye bye, thank you. No, there are reasons behind it. There is physics behind it. There is chemistry behind it, and the reasons are associated. And ultimately, those have to be incorporated in the main plant. So our journey from right from a lab scale, rather a kitchen scale plant, to a demo plant, to a main plant. So today we have ordered our plant is almost 50% constructed. By next year we'll be up and running. And if you ask me, it's always a scary thought that we have so many other business going on. Why don't you build on that? Why would I, after 18 years of career and a nice career in this, why would I take such a big risk of getting into this? But then the team gives you the confidence. And I mean, last 6 months, there have been so many amazing discussions with the government. They understand things. I'm not sitting on any complaining mode today, because when we speak with the government people, when we speak with the government officials, when we speak with the good people who are working on these industries, they're not talking theory. They understand things. Everybody has their own constraints. So my journey in the tax journey has been very, very interesting, right from a very, very difficult time, which is even today, that stabilizing of a plant is a very big challenge. I mean, these plants are not a plug and play plants that you just have a switch on and tomorrow onwards you start getting the production. These are not those plug and play plants. Even if I want to expand my capacity from 20 to 30, even that additional 10,000 tons will have the same difficulty what 20,000 ton will have. But the whole idea is that the training, right from having a common ecosystem with understanding what the customer needs, understanding the basics of fundamentals of the material science and physics and chemistry, to bringing that onto the table. That is what is very important, and I think this is the core what we have focused at TAC. And I mean, it's a beautiful journey, very difficult, but I'm very, very optimistic the way things are happening within the Indian ecosystem. While our first things will be focused towards export, as I had shared in various forms, but our focus is towards export just because the export market is already mature, yet people are looking India as a non-Chinese option. And once my Indian friends come into the space, into a very open mode that yes, I will not take China material and I'm willing to develop the Indian guys, then I mean, growing from 20 to 100 is not something which is impossible. We've seen Chinese companies, they've gone from 10 to 300,000, 400,000. And in front of them, when I say that we are making a 20,000 ton plant, so that's not less than is a big laugh. So I'm very happy that the way things are going, and I'm quite very optimistic about it.
Thank you. I think it is indeed exciting times, I think, especially for people who've been doing this work for many years, but suddenly it's become so much more important and strategic for the country as well, right? So I'd like to bring actually Mr. Kirti here, because we started talking about anode manufacturing as that middle layer, but I think a large part for especially a cathode manufacturer is the precursor material. It'll be interesting to know from you, and there was a lot of discussion in the first half around how value is actually logged into the processing and the refining piece, which is the middle layer. So I'm interested to know that from your journey, how do you see some of the risks being de-risks by the government policy, if at all that's, you think that was helpful? And if not, I mean, because this is also still in debate and we are still thinking about what is the right policy instruments to support midstream and processing, right? So it'll be interesting to know from you what kind of policy instruments should then the government be looking at when it comes to, supporting manufacturers who are looking at precursor material manufacturing now here in India. What's your view on that?
So when we started initially almost 7 years back, we started with the idea of bringing lithium into the country. That was the key agenda. Then with the help of ARCI, we had the opportunity to forward integrate into LFP manufacturing, but one pain point became very, very evident from day one. That is using any lithium carbonate that you pick from anywhere in the world does not make it a viable precursor material for your LFP. So this was a pain point from which our journey started, to then coming to the realization that making LFP is one part of the problem, but then the second part is, building out your supply chain to ensure that you get that same consistent material for your end customer as well. With that said, then we started focusing a little bit more on the upstream. We had partnerships in South America, in Bolivia and Brazil, where we were getting our material from. There has been tremendous amount of support from the National Critical Mineral Mission and also Ministry of Mines as well, who've kind of guided us and Kabil into acquisitions of some mines in South America as well, enabling that supply chain. Parallelly, one other thing that we did was, as part of our fundraise, the only investment that we bought in was from a large iron phosphate manufacturer. So now we have essentially identified the two critical raw materials that are by cost and by quality the most important, kind of made it in-house to build that strong product. With that, now we are at a very cost competitive place, I would say 20% to 25% versus China, even at a 20,000, 25,000 metric ton scale. So that sort of stability is something that we see is going to be the driver, not just the product itself. And in terms of the support from the government, we've been listed under the Mineral Security Partnership as one of the projects for setting up lithium carbonate refinery in the country as well. So there's a lot of policy framework that has already come into place to support companies like us trying to build the upstream value chain. And as well, I think in the recent budget, there's also been the announcement for enabling the setup of a lithium refinery as well. So the policy-wise, we have tremendous amount of support already from the government. I think the only gap that we're trying to bridge, apart from, let's say, the rapid advancements in the product, is large-scale manufacturing at a cost-competitive price. Again, I think we do also have a PLI that is coming into place probably over the course of the next 6 months to 12 months on the entire value chain as well. So that will make it a little bit more easy for not only us, but also other companies in the cathode manufacturing space, anode, electrolyte separator as well, to make it really cost efficient for us to produce in the country.
Great, thanks. I'll come to Mr. Vikramaditya now, because I mean we've heard from anodes, we've heard from people who are looking at processing. It all comes down to eventually cells and batteries. Amar Raja did a groundbreaking ceremony 2 years back on the Gigafactory, and it'll be interesting to know your perspective and how things have panned out since then. In terms of also, what are the kind of, technical collaborations that have really helped you scale up, set up this facility, and how are you sort of like, navigating the manufacturing overheads if they are coming up, and how are you improving on the yield rates with time?
I think the last couple of years have had a couple of rude awakenings for us. When we first started our journey in lithium, I think very similar to how we did in lead acid with technical cooperation, we thought that we can sign a technology license and it'll help to fast track things. I think pretty soon after that, the doors were shut in our face. The Chinese government is not really allowing the type of technical collaboration that we were hoping for. But I think the lessons are, number one, even a technology license, even if it's successful, it doesn't actually transfer capability, right? You have to actually, you can't avoid the learning curve no matter what you do. Dr. Rana brought up a very good point. So our manufacturing journey has been in 3 phases. First is to set up an R&D pilot line. And we did something very similar to what TACC did. We set up a subsidiary under our listed entity because there's not going to be profitability in this entity anytime soon. So we have to give our teams the, enough room to navigate, take risks, and fail. When you set up the R&D line, I think, and especially given that technology cooperation is not coming, now we pretty much have concluded that the technology efforts have to come largely in-house. So a lot more effort on getting the right technology, getting the right people who can develop technology. There have been a lot of non-resident Indians who we've been able to get back into the country. We've been working with bringing talent from all over the world. So I think we don't have to limit ourselves to only Indian talent, but ultimately the talent has to start getting developed in India. The second layer is setting up this customer qualification plant. It's more like a commercial pilot. And if you call a gigafactory the mass manufacturing, you can call this more like a mega factory. These two facilities are now operational. They're just in the final stages of commissioning. And I think what this helps us do, it doesn't avoid the learning curve. Learning curve has to come no matter what. Our yields were not good 2 months ago when we started our qualification line, but they're getting better day by day. But what this does is this is a far more affordable risk to us, I think. And many companies in India have jumped directly into Giga. I think that's their choice. But I feel that our journey is going to be a little smoother. And June of next year is when we're aiming to start the first commercial production at the Gigafactory. And by then, I think there's a lot of learnings that we would have gone through and help us to not necessarily face the same challenges at a much larger scale where the learning is a lot more expensive.
Very interesting point, I think, on setting up a customer qualification plant as a mega factory to test out and improve the learning curve. Dr. Rana, I want to come to you now because I think what we are seeing, as I mentioned, is that we are in early stages of setting up gigafactories, but at the same time, we are also seeing, as somebody who's so close to some of the best tenders, I mean, we are also seeing falling prices when it comes to from the developer community on the power sector side. So it's interesting to know from your perspective, how is the government sort of thinking about a strategy where we are seeing a rapid scale up of battery energy storage deployment on the deployment side, and then we are also sort of picking up on the manufacturing piece because unfortunately India is sitting at a point where we have to do things in parallel. We cannot wait and sort of look at it. So how is the government thinking about which part of the battery value chain do we localize first, and how do we then deepen it?
Yeah, in simple words, so as I have mentioned previously, so we need the all streams, first things. And definitely, yeah, so there was almost like 10-fold installed capacity of the BESS. Last year it was around 0.8, now it became almost 7.5 gigawatt hour of the installed capacity. And by 2047, it is predicted that only for the stationary storage, we may require around 2 terawatt hour of the BESS. And similarly, 7 gigawatt, around 7.5 gigawatt is for the installed capacity of the PSP. So so as in our, the introductory part, so we have mentioned that government is supporting both from the, the supply sides and the demand sides, and already 2 tranche of the VGF support is there, which has a budgetary allocation of around 9,000 crores and to support 43 gigawatt hour of installation. So similarly, manufacturing side, we have the PLI, but from to support that component manufacturing. So there is a discussion is going on, and then for the mining sites or the refining sites, because we don't have the mineral, so we may focus on the refining of the, and we may give the support, already is the proposal is there, so to support the refining of the some major critical components like nickel and lithium, which are the major part of this advanced chemistry cell. And future tendering, so we, the government's level, we have to think about the long duration energy storage. So which may be any, the technology agnostics, it may be the electrochemical, mechanical, thermal, or any one. So the future, in the future, these area need to be supported, and then definitely the tendering process need to be modified for the long duration energy storage. And again, in manufacturing sites, that exports, so how we can have the export our advanced chemistry cell or the containerized BESS. So I think that we have to fill that delta gap, which is from the cost coming from the imported cost of the BESS at the cell level also, as well as the containerized BESS. So that delta need to be supported, already is being supported through the government subsidies and the government schemes, so that cost. Yeah, so that is from the government perspective.
It's back, yeah, thanks. I think that point on bridging that delta is something that we all have to again work collectively as an ecosystem. And I think as things scale up in terms of different parts of the value chain, I think we'll eventually, start hitting that spot as well. Dr. Akansha, I want to come to you because I think the point that Dr. Rana made was, something that, you've been looking at very closely in terms of, what parts do we localize, in terms of, be it the equipment, be it in terms of, I mean, there's just so many machinery that is needed, like, drying oven, calendaring machine. Do we, sort of like also look at localizing the equipment as well when we think about just the cell part of it, beyond like, trying to think about just the critical minerals part of it, which is the mineral access. So, what parts of the cell, in your opinion, are actually best placed to localize quickly? And are there any existing, Indian industries we could build on rather than, just starting from scratch? Because that is where we can sort of think about a comparative advantage within the value chain as well.
Sure. Thank you, Swasti. I think when we look at what do we indigenize first, that can be answered by respondent from different perspectives. So I think an equipment supplier would say focus on indigenizing machinery, right? A component supplier would say focus on component indigenizing, whereas let's say anyone who is making a pack would say, yeah, let's just focus on bringing cells and making the rest of the BMS and the EMS part into it. So I think where do we enter is really subjective to perspective. How at CW we are trying to answer is in a much more methodological way. So in 2024, we did one study which looked at actually very closely on 3 clean energy manufacturing value chains: battery, solar panels, and wind turbines. And our logic was that we did a product space map analysis, like understanding how complex a product is and what is the industrial base that's needed in order to manufacture that product. And we use that lens to then identify what is the latent capability already in our industries today. And our theory was that if we were able to identify these linkages, either in similarity of machinery use, similarity of raw materials, let's say the end product is same and maybe it's the final formulation, the morphology, the dimensions that are different, but what is the proximity that we have in our existing industrial base and the clean tech sectors that are coming up and the components going into it, maybe that would guide us to capitalize and build some of these industries early. And we see many examples on this panel who have followed their theory and are seeing positive results. Now that doesn't mean that we are undermining the R&D and the learning curves that's gonna go into even to make that pivot also. But I think our understanding is that maybe the gestation period and the leap and the time to pivot would be shorter instead of if one has to start from scratch. So that's our approach and theory into it, that maybe if we start looking at our existing industrial base much more closely, identify where is that latent capability, we would be able to pivot. And we have examples on panel, and we also see other movements in industry. So electrolytes being manufactured, separators being manufactured, and synthetic anodes, anodes being manufactured, synthetic graphite, and so forth. So these are the examples where the components could be prioritized in order to, of course, make a more export-oriented and capable product, but also deepen our existing industrial base, which again, would be able to leap dividends in jobs and added in investments opportunities. But I think in order to even make that happen, of course, a lot of efforts going into having the right talent, having someone who has knowledge on both sides, on the existing products that are being manufactured as well as a targeted product also. I was discussing this off stage with Mr. Khaitan, and it was a very valuable insight that while from research point of view, we are making those connections and connecting those dots. I think to realize that, to do that practically, there is of course a lot of capacity and skill power needed. And then the first point that I raised, which was on quality and testing assurance also, because what you are building, even if let's say it's a precursor, a PCAM material, or a cathode, or a separator, or an electrolyte, all of that needs to be verified and vetted so that it finds a place in the finished cell or the battery pack to end with.
Yeah, again, thanks for those interventions. I think very interesting methodology again to map out the value chain and try and identify where our competitive advantage really lies as a country. Dr. Yogesh, I'll come to you because I think you mentioned that we have the two M's. I want to talk about actually a little bit, I think with the experience that you have, which cuts across the industry and the academia industry linkages that we need for everyone to sort of move together. I'm interested in knowing your thoughts on next generation chemistries, because that's also something that, there's a lot of chatter about whether India should again, think about that leapfrog versus pole vault. Do we double down on lithium, or do we think about solid state already? Because there's already innovation happening in that in India, and how do we then sort of support it? If you could also maybe, while talking about that, maybe also help us understand how do we further bridge that lab to market cycle? Because I think that's where still there's a lot of gap. We are seeing so many innovators in the battery technology showcase just next door. How do we sort of support them further?
Thank you, Swasti. This is very important. In fact, I have started battery work back to 2002. So during my master also, we have started working on battery. So, I mean, since my PhD and joining IIT, we were working on lithium-ion battery just to, but what I realized, as I told in my beginning part, like M, so material, machines, and manpower. I mean, these three are very critical, and considering that, we started on the alternative, because, the problem of lithium, problem of some nickel, cobalt, we had something. So, once you start any deep tech, the problem is flow of money. So, pre-8 November is the day when many innovators in India become hopeful. Before 8 November, no one was much hopeful, because 8 November is the day when China restricted export of high technology, machinery also. So when we want to have a big factory, then how we need to translate the technology actually, or translate the innovation which you do at the laboratory level. So mainly in our country, the innovation we do at some scale, say 10 gram scale, 50 gram scale. But when you go to 5 kg scale, the whole scenario will change. When you go to 5 kg to 50 kg, again scenario will change. But we don't have time to get that scenario to be updated, because the fund is missing. When you go to 5 to 50 kg, the duration is long, and the support from maybe from government is needed, or from some industry is needed, because that gap is missing still. So we rely on many of foreign technologies, foreign machineries, but over the period we have to be self-reliant. That is, our Honorable Minister, Prime Minister always say, if we have self-reliance, then only we can be placed on a specific platform when we decide. But we are not at deciding stage at present, we are at receiving stage. So, like what I have started, I mean, 7 years back, we started a startup with my own students called India Energy, thought that we will be making sodium-ion battery in India. So Reliance acquired Ferradin, and we realized, yes, there may be some chances for us as well. So for making any battery, we need material first, because we all know 50% of cost of battery goes to, not battery, cell, goes to material. So we started making few grams, then few kgs, and now we are putting some 200 kg per day small plant to check our methodology at a commercial scale. Similarly, because cathode and anode, both of the things were very important for us, so both the materials we made. Now problem was with the electrolyte. No one has electrolyte. When electrolyte you chose, then the content will change and automatically your cell will be failed. So that is why it's a battery manufacturing is so complex. You need to work on either you work on cathode, anode, electrolyte all together. And then you need to end it with the 10 years down the line, and nobody want to invest that much money. So again, this is a real problem, And everybody is facing, whether it's a startup or a big industry, this is a real challenge. And I hope there must be, I have also a solution. Solution is we must have translational centers. And that must be in public-private partnership, not like professor must be owned by him. Professor or industry club together, work for prototyping. Every industry needs this prototyping center. Every industry, first mega scale pilot is required for any gigafactory. So if that would be made across India, not any specific place, that would be one better thing. And money for doing research and innovation. Probably that also can be taken with public-private partnership, because there are many industry want to have some new technologies in every aspect, but again government will not support everything. So now we have an ecosystem. If it will to be built on that scale, probably public partnership, private partnership is an essential part for better ecosystem to manufacturing the cell. I differ with battery. I don't say battery manufacturing. I say cell manufacturing. Thank you.
Very interesting point. Actually, this is something that we had also discovered when we were doing our work, which we will launch in a bit, States in a Driver's Seat. We actually found that, a lot of the people that we interviewed in the industry actually mentioned that R&D and IP is a bit of an issue. How should the government support it? And we were looking at the semiconductor mission, and it's interesting, the DLI format is very interesting actually that the government has done, which is a design-linked incentive scheme, where there is, a staggered approach to actually supporting R&D, which is you give 40% at the stage of filing the IP, and then 60% at the stage of productization, which is, I think, something that we can think around for the cell part. We don't have an equivalent of it in the battery space just yet. So I'm actually being sent notes by the organizers that we need to wrap up, but I really want to do a little bit of crystal balling, because I think this is a very rich panel. Quickly, if you could give me a 90-second answer to 2 questions that I'll throw out there. You can choose which one you want to lead with. One is, if India had say, just 2 billion USD, and this is more from the perspective of policymakers, so Dr. Rana, maybe you can lead with this one. If India had 20,000 crores available tomorrow for the battery ecosystem, and you were a policymaker, where would you spend it? What would you do if there was a fiscal constraint? I think it's very important to realize that we are talking about all of this in the middle of an energy crisis, where governments are really tied with dealing with the crisis today. So we have to be a little more pragmatic in terms of what we can expect from the government. So that first question speaks to that. The second question, which is also a crystal ball kind of a question, I want to take everyone ahead 10 years and think about you in 2035, and think about a situation where India has succeeded in becoming a global battery manufacturing hub. If you have to be in 2035 and you look back at today's time, what is that one important decision that you think that the country took that determined that outcome of India becoming a successful manufacturing hub? So I'll let you pick your battles. You can lead with either of them.
Yes, if I have that much of money, so I will support complete value chain. Start with the, lower hanging fruits like the containerized BESS, until the cell start manufactured in India by 2030, and then we may go to the components, because component will take some further time. So it required complete value chains, to invest. And definitely that, as suggested, we must have some prototyping centers for the R&D pilot to the commercial pilot, one. Number two, we need there are a lot of testing lab for some pack, few hundred kilowatt pack and cell level, but we need the containerized BESS testing, the facilities in the countries.
Perfect. Thank you. Anyone else who wants to take a stab at it? Yeah, go ahead.
Yeah, I can look back at, I can be in 2035 and then look back what we did right now that helped us reach that scale. And I think that would be, protecting our domestic manufacturers from foreign dumping of products. So basically the traction or the conversation that we are having either on ALBM or local content requirement, I think if we were to implement that and enforce that within the timelines and stick with it, I think we would have reach the future that you're asking us to envision in 2035.
Yes, please.
Yeah. Actually, if the money is given to us, I would propose for, as Kuldeep ji said, yes, we need to give all sector, mainstream to upstream. So why I say, I mean, we have a very good ecosystem for lead acid battery in India. Even a small mechanic can build a lead acid battery in a small village. That system is needed for this advanced battery also. The difference is we always look for gigafactory. That is not required maybe for some reason, it may be for when you look at the whole end-to-end system. But if you decentralize the money, people must work on electrode first. So electrode manufacturing, if you talk about that, money is, capex is different. And assembly is different. If you put everything all together, it goes to 1,000 crore. And investing 1,000 crore in the beginning and considering the anxiety of the material, supply chain, then nobody want to invest. So probably decentralize the whole process, make it in steps, and make the same model as of lead acid battery. I think that will be the best ecosystem for us to survive.
Very interesting. Mr. Khaitan, you wanted.
Yeah, I would love to build on the 2035 question because, I mean, if we are sitting, suppose today is 2035 and probably the same panel is sitting together.
Just with a little more gray hair on more hairs,
Yeah,
or maybe
probably,
no hair at all.
at least myself, probably completely bald. So, but one thing which surprises today is that, not surprises in a very, very positive way, that finally we realize that, in last 10 years, India is the biggest manufacturing hub outside China. Where China was 30 years ago, India was somewhere very different at that time, and today we have learned a lot of things from countries like China, and we have been able to capitalize the manufacturing strengths of India. Apart from that, our dear friends here, whether it's a cell manufacturer or a component manufacturer or a aspiring component manufacturer, the kind of risks which had to be taken, they have been taken, and nothing. I mean, no cell company would want to work with a PPT anode player. They would want something concrete to happen on ground, and why? So these are the risks which have been taken in the last 7-8 years, which have shown today a very different vision of India, where at least we can confidently say that when we are talking about 440 gigawatt over 2035, then maybe it's not 440 today, but it is still around 200, which is deployed into various aspects of within India, which is a moment of pride for all of us.
I don't think just a 20,000 crore kitty is going to solve all the problems, very honestly. Because if you look at, touching back on my first comment on the day, there's already different clusters, different sectors to which the government has given out a lot of money, a lot of support, not only financially but otherwise as well. So I don't think that is just going to solve the problem. I think coming back to your idea as well, clustering, joint working between these industries, and I think we need to evolve over time. I think, like my colleague was mentioning, we just need to spend the time to build the capacity. And I think one thing that I always tell a lot of customers and a lot of people that we work with overseas as well, that I think India is going to take its time building the first 3 to 5 gigawatt. But the day we get there, from there jumping to a 50, 70, 80 gigawatt is going to be a much, much easier job for us as a country which has really strong engineers. I think that is the problem that we'll unlock. And that is a problem that we'll have to unlock as well. And I think that is a journey that we'll have to take over the course of the next 5-7 years.
I think I share the optimism of my co-panelists. I think the important thing for me is not the amount of money, but any policy that we recast has to go through a different methodology. I think the bidding process, the L1 bidding methodology is not going to work in high-tech industry. So if I look at, you called out the semiconductor mission, I think it's been very successful. They've had a high-powered committee, an empowered committee of technically capable people who assess product market fit, source of technology, DPR, including the technical details, what is the exact equipment that you're proposing, what is the process that you want to use. And I don't think it should be like one player taking all of it. Back 5, 6, 7, 8 projects, it doesn't matter. Cap the amount of support given for each one. But you have to be far more strict about imposing penalties for people who are not delivering. And on top of that, I know there's some real financial constraints. But I think another policy I followed very closely, which I'm able to appreciate the logic behind, the solar localization policy through ALMM, Dr. Akanksha mentioned in ALBM. But I think the point of that is not just money and blocking and protecting Indian companies, but it's announcing well in advance the localization expectations. So if you say by year X, cell has to be made in India, then whether it's 1 year later, 2 years later, make it very clear, this is how much of your cell material has to be bought locally. Because I don't think that each layer, once we achieve it, we should pull up the ladder and not allow the others to also succeed. So I think I depend on any of these people the same amount that they depend on me. Ecosystem has to develop, and it's going to only develop if we're very open-minded about it and ask the hard questions.
Thank you. I cannot wrap this up with a better answer, so I'm just going to wrap it up. Thank you. I think that was an excellent discussion, at least for me. I take back a lot of interesting points. I think in terms of just, how are we thinking about providing incentives? What's the model of bidding under it? How do we innovate with, sort of models where we have more regional PPP innovation centers where academia and industry can sort of do the prototyping collectively. Very interesting, again, interventions on how do you think about the entire value chain, but with a road mapping for localization, which can give the right policy signal and the market signal that's needed for different players within the value chain. And then again, the point that Dr. Akansha made, I think, on the standardization, setting some of the quality protocols in place will also help and enable some of that market signaling as well. So I think very rich discussion. Thank you again, everyone, for taking out the time and coming. I know some of you have traveled to New Delhi for this, so thank you so much and participating in the Battery 360 Summit. The intent of the Alliance is to actually do that trust building and ensure that, we all sort of keep speaking to each other, try and understand the challenges that, different parts of the value chain sort of are facing, and then work collectively towards a common goal. So thank you again. Very rich discussion indeed.
Thank you so much. Thank you, Swasti, and our panelists for that enriching conversation. We would now like to invite Ms. Swasti to felicitate the panelists with a token of appreciation. May we kindly request the panelists and moderators to please remain on the stage as we launch the report, States in the Driver's Seat, Policies Localizing Electric Vehicles and Battery Manufacturing in India. We also request the authors to please join us on the stage. This report examines opportunities for the states in India to strengthen domestic battery manufacturing ecosystems and attract investments, To mark the launch of this report, may I request our panelists and the authors to kindly pose for a photograph. Thank you so much, panelists. Thank you, Swasti. We now move into a side chat conversation on the future of India's battery ecosystem. Please welcome Mr. Vijayanand Samudrala, former CEO of Amaraja Advanced Cell Technologies. Over a distinguished career of more than 3 decades, Mr. Samudrala has played a significant role in shaping India's battery industry and advancing indigenous manufacturing capabilities. In conversation with him, we have Mr. Madhav Pai, Chief Executive Officer, WRI India. Please join me in welcoming both our speakers to the stage.
Good afternoon, everyone. So we'll keep going. I think you'll get a tea break after this session. After the final session. So, actually, my notes. It's my honor and privilege to introduce you to you, Mr. Vijayanand Samudrala. He was the former CEO of Amar Raja Batteries. But I think I'll give you a little bit of his career, a little bit of insight into his career. You know, he's a chemical engineer by training, and he spent almost 30 years at Amar Raja Batteries, and really, moving into positions of marketing, research and engineering, business leadership. So he's been on all sides of the business, and to a large extent, I think the conversation that was just held in the previous panel, I think he has been through that journey. So as we think about India's battery future and the crystal ball gazing question that was asked in the previous session, I think we'll start with him taking us back a few years and then forward and help us think about how India should be thinking really about moving forward on this whole big problem of the battery. So yeah, Mr. Vijayanand, thank you very much. It's an honor to have you here. And I think just you're one of the unique people now in this ecosystem who's been around for so long and have actually done this whole commercial journey, right? So would love to hear a little bit from you also. Just I think what were the few things that you learned along the way in building the whole lead acid battery ecosystem, right? Maybe if you can talk about a few things, and from the sense of its relevance to now what is happening in the current system, right?
Yeah. Thank you, and thank you for having me here. It's a pleasure to have this conversation along with you, because WRA has done vast amount of work in the sustainability space. I started my career with batteries back in '92, when batteries were hidden away from sight. They're more like an apology word. You won't do that if you have a battery at home, you put it under the staircase. The battery in your car is anyway under the hood. And even if you go to a telephone exchange, those days the landline telephone exchanges, the battery room used to be at the corner of the building, with acid-proof tiling and exhaust systems and all of that. So, and even a consumer, when they make a choice of buying a battery, it's under duress. So we call it as a distress purchase decision. They are not buying it for pleasure, because already the existing battery has failed and they need something immediately. So there was nothing very attention-seeking about batteries those days, and hence not much was talked about. So over the years, we have seen that the energy storage as a solution has taken center stage. Initially, when Amaraja, I was part of Amaraja at that time, and when Amaraja started working on battery industry, we clearly recognize that there are white spaces where technology gaps exist, even within lead acid space. Our founder chairman, being a technocrat who worked in the thermal power generation control systems, the DC power supply as an emergency was very important element. And he realized that there were gaps in the way they were being run here. And that's when we brought in a state-of-the-art, at that time, the state-of-the-art technology called advanced absorbed glass matrix wall-regulated lead-acid batteries. So while within lead-acid space, Amaraja has innovated by bringing in the globally contemporary technology and popularize it. But then when I look back at the journey, the volume momentum came from an unexpected quarter. The liberalization happened in 1991, but 95-96 we saw the mobile network getting established in India. And hence, we needed energy storage backup systems in a very widely distributed, unmanned sites of mobile towers. And hence, the battery technology that was existing at that point of time would have never met the requirement, because you can't have people sitting there and topping up with electrolyte and maintaining them and all of that. So a maintenance-free wall-regulated lead-acid battery technology was a perfect fit. That was not part of the strategy with which we came into the country, but I think we were at the right time, at the right place, with the right product. That transformation happened as the mobile network started becoming bigger and bigger in the country. The speed at which deployment was done. So during the course of the day, when I keep hearing about this self-reliant battery ecosystem, I think unknowingly we made that happen with the lead-acid battery industry in India, where the mobile networks expanded with self-reliant capability in India with the new technology within lead-acid space. Same thing as internet took shape, computerization started happening in schools, government offices, healthcare facilities and all of that. The UPS importance became significant. The grid was not very reliant at that time. There were a lot of blackout, brownouts, and hence the UPS systems became important. This product again fitted pretty well with the UPS systems. So when I look back, I think the lead-acid industry need to be credited for bringing self-reliance without necessarily being worked as a conscious effort. It's an intuitive effort that made it happen. So sometimes I feel bad when we go and talk to stakeholders and policymakers that, lead acid, that's gone, that's old. I said, I think if we can replicate what we did with lead acid with lithium, we would do a great job for ourselves.
No, fantastic. And I think it is great to hear this. And I think also for a lot of young people, I think this is a good story to hear. But I think now, we are, this whole building at home in this context of whether to build lithium capabilities or to move to sort of some next generation chemistries, conversation is going on. And there is this whole competition. I mean, of course, no conversation on battery could be had without talking about China or Korea. And, I think from, say, mid-90s to where we are today, 20, 30 years later, that we all know the possibility of the global value chains and how easy it is. But now in the recent years, we've also seen the shocks. So in that context, I think, how should we think about building at home this capability? So based on your past experience, but also in this new sort of geopolitical and globalized context, what are your thoughts on how we should sort of think about it?
I think 90s and the first decade of the current century, globalization was probably the thing to do, right? Companies started looking for markets outside their domain, and hence India was an attractive market. It evolved as an attractive market over a period of time. Indian companies went out and tied up with many other things. The best example is to look at how automotive industry evolved in this country. Maruti was probably one of the early automotive company that brought in Suzuki technology into this country and built a whole lot of ecosystem around that. The supplier base, the standards, the Japanese industrial standards were brought in because of that. So along with that, I think next wave of automotive industry revolution happened when Hyundai entered with their Santro vehicle, and then there were Europeans coming in, there were Japanese coming in. So late 90s and the first decade of this century, you saw a lot of automotive buzz happening. And somebody said in the previous panel discussion that automotive industry probably would be a benchmark of manufacturing powerhouse, provides 7% of the GDP, half of manufacturing GDP, significant number of employments and all of that. How did that happen? If we had the protectionism that we are talking about today, nationalism that we are talking about today, we wouldn't have probably been able to see that kind of percolation of knowledge, percolation of technology. And automotive industry has been truly global in its character. But also we got to see that we didn't just say we will do cut and paste of technology. There is, I was part of many of the workshops, how quality movement happened in the country. You buy a car today, you're not too much worried about the performance of the car at all. It's given. The reliability of the car is given, the standards are there, the validation methods are there, and young engineers in India have learned, people who are part of TVS group, people who are part of Rane group, who are part of the Mahindra group, they all build that skill set in them. That's where internalization has happened. And but in the last, say, post-COVID at least, you see that there is protectionism that's at play, and globalization is not necessarily getting the tailwinds that we have had earlier. But when we look at segue into battery ecosystem being built in India, I don't think we can afford to reinvent the wheel from scratch. I think we will end up spending a lot of resources, end up using a lot of time to just do what has already been done. I think we have to figure out ways and means of adopting and absorbing technology that's already existing elsewhere, but ensure that they're deployed in the Indian context in a manner that it fits into Indian conditions. Whether it is the manufacturing supply chain or whether it is the applications that we talk about, that responsible adoption of technology to fit you. I'll give you an example. I go back to the lead-acid ecosystem that we talk about. Indian Railway air conditioning coaches have moved from 48 berths to 72 berths at some point of time, if you recollect. There is the three-tier AC that's been introduced. That was possible because of batteries. That is surprising, because you had a bigger battery capacity being built into the railway coach to be able to support 24 more berths when the self-generation is not happening. That was customized for that application. Nowhere else in the world it's done. The core battery technology is still AGM VRLA, but the application that was adopted was specific to Indian Railway network. Similarly,
and there actually that's the advantage of India. You had the scale, right? Because
absolutely, yeah.
So,
you had the market to meet,
yeah.
and you had to work with the customer. Similarly, in the lithium context that I am saying today, there is no lithium battery pack and lithium cell that has been custom built for motorcycle application around the globe. But that's what is actually taking traction in India. So how are we understanding the lithium manufacturing of lithium cells, packs, thermal management, the software built into that, that's customized for two-wheelers. I think that's a localization that we should spend, not go back and invent cathode and anode as the state of the art as it exists. Doesn't mean are we going to rely on electrode and electrochemistry forever? No. I think there got to be a pilot track. A lot of discussion happened on how do we build a technology capability, but don't get to the building technology capability from scratch, because you're going to lose time, you're going to lose resources. Think about the next generation technology to be able to do that.
Absolutely, and on that point, I keep saying, I think, e-rickshaws, India, has 2.5 million e-rickshaws, and I think for the dust and heat conditions, I think it's a unique opportunity to build a very localized product, and I think that's something. But
I just want to add another application. We all will be probably not aware of it. Today, there is only less than 1 gigawatt hour of grid-connected energy storage systems that are deployed in India, while 40-50 gigawatt hour of projects in the pipeline. If you cumulatively add entire energy storage or a battery system sitting in our own homes as inverters, it is equal to 50 gigawatt hour. So the cumulative energy storage sitting in our residential systems through inverter batteries is 50 gigawatt hour, and every year we either replace or add new installations equivalent to 20 gigawatt hour, and 99% of them are lead acid batteries today. With lithium, what is the solution we have for that? Affordable, safe, and value for money kind of a thing for home energy solution. These are the challenges that definitely we need to address.
No, absolutely. I think coming to the next question, and I think you spoke about it a little bit in your opening address. Also, we know, in this journey, the midstream is the hard part. So from your perspective, I think, how should India think about midstream? And I know you spoke about it, but I think if you just, how should India think about midstream, and what kind of, I think, policy level, or I mean, I know one, also if you were now to sort of think about building this for the ecosystem, what would be the 2-3 policy directions that you would think would be useful to give?
So I did make certain recommendations in my opening remarks about the midstream. How do we do that? One is about access to minerals, because India may not have every mineral available in our natural resources. So this access to minerals cannot be solved by individual companies. So there is a national, concerted effort that need to happen, and government has started making things move forward on that. But we need to accelerate. Number one is access to minerals. Number two is the refining technology capability. There are parallel industry where similar success has been achieved. I think we can replicate, look at what is the strength India already has in this space in terms of metallurgical processes and the specialty chemical processing capability. The third is about converting the refined minerals into battery grade materials. Again, it's about specialty chemical industry. Pharmacy industry has done fantastic job in India. The bulk metallurgical industry have done fantastic job in India. Specialized chemical industry has done good job. We'll have to replicate some of those successes here. But specific technology required to make it happen, we may have to again access that technology. In my view, to do certain things by keeping China completely away would be an extremely challenging thing. One is from maturity of technology, which China has achieved, and two is about the cost effectiveness. Yeah, at some point of time, we may have to build a lot more self-reliance, but if you say that I'm going to do it without China, you are choosing a difficult path. Let's acknowledge that. And then fourth thing that I talked about is about the investment in R&D capability, and fifth is about circular economy. I think midstream need to look at an integrated approach considering all these aspects. From a policy perspective, as I said, the first formula that I talked about, accessing minerals, I think government need to be the anchor. That Kabil or whatever other frameworks that we have, they need to happen. Second thing is recently 3,000 crores of incentive money has been announced for material processing in the upstream battery materials or critical minerals. Yes, that is something that need to be taken care of. And fourth, the third is, previous session talked about 20,000 crores. If you have, what will you do? Sitting there, I was very tempted to walk onto the stage and say what I will do with that. I think I think we need to put significant amount of that money behind R&D. Public-private, R&D institutions need to be developed. Transnational infrastructure need to be built. There has been a discussion earlier about rapid prototyping center with the DST being involved. I made it very vocal in my recommendation that don't distribute 500 crores to 10 individual institutions at 50 crores per institution. Democratize it and then replicate what has been done. It takes a lot of effort. In fact, one example that I have is Fraunhofer and one of the city in Germany that I'm not able to immediately recollect. They have built a 600 million euro electrode prototyping center. That's a level of work that's getting done elsewhere. We may not be able to afford something like that, but we have built a commercial pilot plant in Amar Raja, to demonstrate mega scale capability. We may need 3 such facilities in India. Each of them costs about 300 crores. So if I have 20,000 crores, these are things probably I'll try to see. Because that's, something that you're building for future, something that will give us the kind of self-reliance that we are talking about.
Super. I think, one last question, but I think, you at Amar Raja, led the groups move into these advanced chemistry cells, and the Giga Corridor that you created, which was like a 10,000 crore investment, with a decade-long sort of effort to build that sort of lithium building capability. So, I mean, my question is, this financing challenge, right? When we start talking about these gigafactories, etc., I think how how should we be thinking about financing this sort of journey to build this sort of large-scale capacity to do battery manufacturing? What are your thoughts?
I think there are some segments in Indian growth story that are not to be seen with the same lens as typical project financing is done. I think we talk about semiconductor industry as one aspect of it, battery materials and energy storage technologies as another aspect of it. These require a much long-term view, and the patient capital is what I define there. It will eventually deliver significant value for the organization that is investing, the lenders who are supporting, and of course, in general, for the nation as a whole. So you really need a different set of metrics. If I were to look at a brownfield expansion of an existing business, maybe I will say, do I have 14, 15% EBITDA, and hence, only then I will do. Whether my return on investment is better than what I would otherwise get from a more risk-free investment, then I will do, otherwise I will not do, because I'm taking risk, I should get more return. I don't think here it works like that way. But then why would somebody put in money if there are no returns? That's a fundamental question, right? Why would money chase an opportunity that's risky? This is where we need to distinguish what I call as risk capital, and then certain amount of institutional framework support is required to tolerate the risk capital. And the time frame that we are talking about for returns have to be seen slightly differently. I wouldn't know if, for example, you are establishing a national highway. What's the returns on that? These are measured in multi-year toll collection and things like that. Similarly here, at least my experience says that there is going to be negative cash flow for any gigafactory for a period of 5 to 7 years. Then you might see that at least you're breaking even from a cash flow perspective. And as you scale up to a level where the efficiency is brought in, little more stability and offtake agreements are there, plant operational metrics are really stable now, and you see directionally that your supply chain has been secure and competent, that's when you see that your margin levels will go up. So the risk capital for the first 5, 7 years, sometimes even stretched a little beyond that, is something that lenders have to have a perspective of it.
I mean, this is like the metro capital, right? 35-year lending, we're using some kind of
we have public infrastructure tolerance for that kind of a mindset, but when it's a private investment, lenders probably find it difficult to support at this point of time. But I think we need to have a capital structure that should be able to enable this, for this to really get to there. Otherwise, you will see a lot of burnouts happening in between that we have seen elsewhere in the world.
Yeah, so I think this narrative that, this is patient capital is required for this long-term ambition to achieve, and then structuring it right, and then how do you bring, measures to reduce the risk on some of this to make it patient capital, I think becomes really the financing challenge to solve on the batteries, right? So
absolutely. And there was a question, but 2035, when you want to have a crystal ball gazing and then look back to say what went right, what went wrong. At this point of time, a viable cell making in India that is also connected with the upstream material making, it would be impractical to think that the Indian made cell will be able to compete with cells made in China, for example. So, and hence there is going to be a cost delta when you think of that project. Now, this cost delta need to be bridged. If the cost delta need to be bridged by those people who are actually making that investment, they'll sink further. So nobody is going to take that risk. So there are going to be some kind of government intervention to bridge that gap partially. Government cannot bridge fully. There is, for example, tariff barriers or capital subsidy or certain other incentives like PLI. You're going to say that government will handhold you, support you till you pass that, they call it a valley of death for battery industry. Till you pass that valley of death, government will have to support. Then there is some additional delta where the project metrics need to tolerate, which is where lenders have to pay attention to that, saying that, look, I can't expect 3-year return on this. So project metrics, which means that I'm saying EBITDA will not be 14%, for 7 years EBITDA will be single digit. And depreciation interest is very high. So you have single digit EBITDA with a high depreciation and interest. How does the project economics work? They won't make sense at that point of time. That's the second delta that need to be bridged. And the third delta is where The customers who are looking for that localization has to pay what I call as a security premium. You're trying to secure your supply chain with locally made cell, so you got to pay premium for that supply chain security. All of this applicable for that phase where you are passing to the valley of death for the battery industry. Maybe after that, obviously, it has to survive on its own merits.
No, thank you. Thank you so much for sharing your wisdom and your experience. Please, one big round of applause for. Thank you so much.
Very much. Thank you, Madhav. Thank you, Mr. Samudrala. We request Madhav to please felicitate Mr. Samudrala with a token of gratitude.
Thank you so much, speakers. Throughout the day, we've explored building blocks of a self-reliant battery ecosystem, from critical minerals, manufacturing, to innovation and market development. As we move into our final session, we turn to a crucial piece of the puzzle, circularity. How can India maximize value for batteries beyond the first life and build a truly sustainable battery value chain? That's the focus of our next discussion. Our final panel for the day is Closing the Loop, Advancing Battery Circularity and Second Life Pathways in India. In this panel, we will explore how India can build robust systems for battery recycling, reuse, second life applications, and end-of-life management while creating a truly circular battery value chain.